Could a tiny tube really burst a barrel? The story of Pascal's hydrostatic experiment, Imagine, this 17th century France. A chilly winter breeze passes through a small village square. A crowd gathers, curiously watching a rather peculiar experiment unfold. In the center stands a large wooden wine barrel filled to the brim with water. Attached to the top is a long, thin glass tube stretching 10 meters straight up into the air. It's so tall, you have to squint to see the top. The tube is directly connected to the water inside the barrel, a continuous, seamless flow between the two. People begin murmuring, "Really? Just pouring a bit of water into that tiny tube. We'll burst the barrel? Come on, maybe it'll overflow a little, but break the barrel? No way!" But the scientist, Blaise Pascal, simply smiles. Quietly, he climbs to the top of the 10-meter tube and begins pouring one bucket of water, then another, carefully, slowly, steadily. The water slips down the narrow tube, joining the water already inside the barrel. Together, they become one column, one continuous flow of pressure. As the water rises, those standing nearby can sense it. Something is building. Inside the barrel, the pressure begins to grow. The taller the water column, the greater the pressure at the bottom, and then, boom! With a loud crack, the sturdy-looking wooden barrel explodes from the inside out. Gasps echo through the crowd. Eyes widen. A stunned silence settles in. How could just a few buckets of water cause that kind of force? The secret lies in Pascal's principle. Here's what Pascal discovered. A fluid in a confined space transmits pressure equally in all directions. And the key? It's not the amount of water, but the height of the water column that determines the pressure. That pressure is calculated as pressure equals the density of the fluid, multiplied by gravitational acceleration, multiplied by the height of the fluid column. So even though the tube held just a little water, the fact that it stood 10 meters high meant it exerted a huge pressure at the base. That pressure was evenly distributed throughout the barrel, until eventually the wood simply couldn't take it anymore. It wasn't just a dramatic stunt. Pascal's experiment demonstrated a principle that would go on to power hydraulic presses, car brakes, and even elevators. Modern technology owes much to this elegant, simple demonstration of how pressure works in fluids. And maybe today, there's something to take from this. You might feel like the strength you have isn't enough, that your voice, your effort, your impact, they're too small. But if your effort is applied in the right place, through the right structure, even something small can build up incredible force. It wasn't a flood that broke the barrel. It was a tiny tube and a column of water reaching just high enough